All right, in this video, we are going to go over another example in Microsoft Excel using the simplex method. We'll do it together, and it's on the computer profit example. So it's about a computer company that manufactures different kinds of microcomputers. Up to this point in Module B on linear programming, we've discussed the uses for linear programming and some of the different definitions with linear programming, the simplex method, the answer report, the sensitivity report. And so what we're going to do in this video is we're going to go through one more example together, the computer profit example. We'll do it in Excel, and then we're going to have a what-if analysis. So in the last video, kind of told you what the answer report and the sensitivity report did, what it meant, how you could find out what the optimal profit was, what your decision variables were. We talked a little bit more about the constraints and shadow prices and things like that. Well, in this video, we're going to walk through what happens if the business environment changes. So generally changing the availability of our constraints or the profit of our products. What happens when those kind of variations happen in our business environment? And does the linear programming model that we've created, does it still work? And if so, what is the impact to profitability? So that's what we're going to go over in this lecture recording. If you guys have, you've all been with me now for either a couple months, and we've done a couple exams together, lots of different quizzes together. What you will see in this lecture recording is a lot of good content that I will probably use again to ask you in quizzes and exams, because you'll be able to see that I can ask questions about, hey, if profitability changes by this much, what is the impact? Or if we find more availability in our manufacturing facility, with this constraint, how's that going to impact our profitability and things like that. So these are there's some very good exam questions that can come out of the topics that we will cover today. All right, so computer profit example. Let's dive right into this first slide. We've got a firm that assembles computers and computer equipment and is about to start production of 2 new types of microcomputers. Each type will require assembly, inspection, and storage space. The amounts of each of these resources can be dedicated to the production of the microcomputers is limited. So they've got a limited amount of resources that can be dedicated to building these products. The manager of the firm would like to determine the quantity of each microcomputer to produce in order to maximize profits generated by the sales of these microcomputers. So you can see you've got your type 1 and type 2 computer. Your profit per type 1 computer is $60. Your profit for type 2 computer is $50. Again, that's profit per unit. That's not your cost and that's not your revenue. It's your profit. It takes 4 hours of assembly, 2 hours of inspection, and 3 cubic feet of storage to build a type 1 computer. So assembly, inspection, and storage, those are your constraints. For type 2, you got 10 hours of assembly time per type 2 computer. You've got 1 hour of inspection time, and you need 3 cubic feet of storage to build a type 2 computer. Now, I've got this little red block around 10 hours, 1 hour, and 3 cubic feet. And that's just to highlight that constraints can be mixed in their unit of measures, but your objective function coefficients must remain the same. So it's okay that assembly is in hours and inspection is in hours, but storage space is in cubic feet. That's acceptable. But everything else has to remain the same. You can't have assembly time for type 1 be 4 hours, and then you can't use some other kind of measure in type 2 for assembly. They've got to remain the same. Okay, and then just for your constraints, your available amount of time per area is assembly. You've got 100 hours, inspection, 22 hours, and storage space, you have 39 cubic feet. Okay, so our left-hand side inputs, when we go to put this into Microsoft Excel, are our decision variables, and our right-hand side is the feasibility and our constraints. So let's real quickly recap everything that we talked about on that overview of computer profit. So our decision variables are what? These are the types, the quantities and types of computers that we want to manufacture. So X1 is your number of type 1 computers to manufacture, and your X2 is your type 2 computers. I think I said this in the last lecture recording, but if I don't tell you X1, X2, X3, then just go in order of what is provided to you. Your objective function is to maximize profit. So the formula for that will be maximize Z equals $60 of profit per X1 that's produced, plus $50 worth of profit for every type 2 computer that's produced, subject to our constraints, which are 4x1 plus 10x2 is less than or equal to 100 hours for assembly. So it takes 4 hours for every type 1 computer to assemble them, and 10 hours for every type 2 computer to assemble them. You've only got 100 hours available. For inspection, it's 2 hours per type 1 computer, and 1 hour for every type 2 computer, and you only have 22 hours of inspection available. Your storage space is 3 cubic feet for the type 1 and 3 cubic feet for the type 2, and it's less than or equal to 39 cubic feet. And everything must be positive because this is a linear programming equation, and you can't make negative of either your type 1 or your type 2 computer. So let's put this into Microsoft Excel real quick and let's solve for this problem. Okay, for computer profit, our example that we're going to go through together, you can see I have already typed in all of our different inputs into Microsoft Excel using the same methodology that we used for the last example. The only difference this time is that now there are 3 constraints. So we have assembly, inspection, and storage. So there's 3 different constraints, but we will input them almost exactly the same way into Solver that we did our last example. So your X1 is your type 1 computer, your X2 is your type 2 computer. Your left-hand side constraints are noted here. Your right-hand side is the total amount available of each constraint. Your objective function is written out as the type 1 computers make $60 multiplied by however many the linear programming model determines we should make to maximize our profit. Our type 2 computers are $50, and we will solve for how many type 2 computers we should make. Subject to all of our constraints, which are assembly, inspection, and storage. So I've got the formulas already put in. You can do these, you can pause this recording and input everything as I've got exactly into Microsoft Excel if you'd like to do it with me together. So here is everything in Microsoft Excel. I'm now going to click on Solver. Okay, and I'm going to set my objective function. We are maximizing profit. Make it so that you guys can see. We are maximizing profit, so we're going to click on max. Our decision variables are in B9 and C9. Subject to our constraints, this time there are 3. So I'm going to add my constraints for, oops, sorry, I'm not going to do that. I'm going to click this button. D5, it is now less than or equal to my constraint of 100. So I've added assembly constraint. Now click add and not OK. Now go to inspection. This is my left-hand side input. It's already noted as less than, so that's good. Now my right-hand side constraint is 22 hours maximum. That's available in inspection. And now for storage, my left-hand side input is that cell, D7, is less than or equal to my total available storage space, which is 39 cubic feet. I've now added my 3 constraints, so I can click OK. You can see that Solver brought it up again as GRG nonlinear, which is not what I want. I want it to be the simplex linear programming method. And now I'm going to click Solve. Okay, it says Solver found a solution. All constraints and optimality conditions are satisfied. That's good. That means I have input the data correctly. I want to see an answer report and a sensitivity report, so I highlight those 2 and click OK. Down at the bottom, I now have my answer report, which shows my objective function as 740, my solution values or my decision variables of X1 and X2, which are my type 1 and my type 2 computers, at 9 and 4. And then I have my assembly constraints down at the bottom. We will go over the difference between binding and not binding in just a second here. But you can see it's a little different than the example we saw yesterday because assembly does have some slack. Now we go on to our sensitivity report. once again, 9 and 4. That's how many we're going to manufacture of the type 1 and type 2 computer. We've got our profit per unit, and then our in our range of optimality, we've got our allowable increase and our allowable decrease per decision variable. And then down at the bottom, we have our constraints, which is our range of feasibility. Okay, so we have now solved for computer profit example. We have our answer report and our sensitivity analysis. So let's go through what that means together and how when we change some of these inputs, it changes, when we change our inputs, it's going to change our outputs. So let's do that now. Okay, so this is our answer report. And what does it tell us? Well, it tells us that our maximum profit is $740. We're going to build 9 type 1 computers and 4 of the type 2 computers to achieve our maximum profit. Our constraints are maxed out in inspection and in storage, but we see something a little bit different this time. We have 24 hours of slack. We're only using 76 hours of the available that we have. That's why it says that it's not binding. So because it's less than or equal to, we have 24 hours of slack in the assembly area. So this is our answer report, pretty straightforward. $740 of profit, 9 and 4 is our product mix, and then those are our constraints. Okay, so now let's move on to the sensitivity report. Okay, up top, we have our range of optimality. And we went over this in the last video where we're going to be making 9 of the type 1 computers, and it's $60 profit per unit. So 9 times 60 is $540. You're going to be making 4 of the type 2 computers, and they profit $50 per unit. So that's $200. So when you add $540 and $200 together, you get $740, which is your maximum profit. Now, if someone in supply chain goes and reduces the price of your cost of goods sold and makes your type 1 or your type 2 computer more profitable, then you need to look at your range of optimality, and as long as it goes up by $40, which is pretty significant, then this model is still valid. You can use, you will still make 9 of your type 1 computers and 4 of your type 2. Let's say if marketing decides to drop the price of the unit and your profit goes from $60 down to $55, well, you can go down as much as $10 because that's in the range of optimality, so you're still good there too. So we'll go over a couple examples of that in just a second, but this is your range of optimality. Your range of feasibility is for all of the constraints that you've got for assembly, inspection, and storage. And again, this one's just a little different because you have 24 hours of slack in assembly. What this number means in the allowable increase for assembly means it doesn't matter if you get more assembly hours available because you're already not using what you have. So that's essentially the number for infinity. And so if you get more hours, it doesn't change the model any because you already have excess anyway. You've got 24 hours of slack. So it doesn't matter if you find more availability in assembly, it won't change your profitability any. And then lastly, you've got your shadow price. The reason this one is 0 is because what I just mentioned. If you find more availability in assembly, it's not going to affect your profitability because you already have more than you need. In inspection, if you can get more availability, or you can find more hours in inspection, you can go from 22 hours to 23 or 24 or 25, whatever it may be, then every time you get more inspection, then you use your shadow price to increase your profitability. So if you can find 1 unit of inspection, then your profitability goes up by $10. Now, yesterday, I was explaining shadow price on the last video, and I realized when I was rewatching myself that I said, don't mix up price and profit. And then I gave an example where I mixed up price and profit. Okay, so your shadow price, if you can find 1 unit of the constraint, it goes up by your shadow price. So if you can find 1 unit of inspection, then your profitability goes up by $10. Okay, that is not your price, it's your profit because we are looking at maximizing profit. In storage, if you can find more cubic feet, then your shadow price is the increase to profitability, so it would go up by $13.33. Now, if you have to spend $20 in inspection to get 1 unit of capacity, then you would not do it because you're only going to make $10 in additional profit. So you would only pay to increase inspection less than $10, and then that will increase your profit. Okay, so in inspection, when you get 1 additional unit, you get $10 more to your profit. So if you're going to spend $5 to get that capability, that's great. $10 is your shadow price, which means your profit's going to go up by $10. You would spend $5 to get it, so you would net $5 of additional profit. So just keep in mind that I said it a little backwards yesterday on one of the videos. So keep in mind that shadow price is the amount that you will see increase to your profitability if you can find 1 unit for your constraints. Okay, so let's do a what-if example. We will go through the answer report and sensitivity analysis, and we'll go through some different scenarios if your business dynamics change and your inputs change. So we're going to ask 5 questions. Number 1, what is the optimal profit and the optimal product mix? Then, suppose an additional 1 unit of capacity becomes available. How will this affect the optimal profit? Okay, so let's walk through these together. So, the first question was, what is the optimal profit and the optimal product mix? Well, your profit is 740 and your product mix is 9 of the type 1s and 4 of the type 2s. Pretty straightforward question, pretty straightforward answer. So 9 units of type 1, 4 units of type 2, and your optimal profit is $740. Now suppose an additional 1 unit of capacity becomes available. How will this affect the optimal profit? So let's say we find an extra hour of inspection time. Okay, an extra hour of inspection time. Well, I just talked about that for the last 2.5 minutes. So your shadow price is $10. Okay, so what you will do is your profit would increase by $10 because you found 1 additional unit of capacity. So your shadow price is $10. Your optimal profit was $740. So $740 plus $10 gives you $750. So your profit increased by finding the additional capacity in inspection. So what about assembly time? Okay, so what happens if we find an additional unit of capacity within assembly? How does that impact our profitability? Well, our shadow price is 0, and we have an unlimited amount of assembly based off of our current other constraints. So it makes no impact to our profitability because the shadow price of 0 means if you get additional hours of inspection, it doesn't matter because you already have too much anyway. Okay, and then what about an extra cubic feet of storage space? Okay, storage space, your shadow price is $13.33. Our maximum profit was $740. So you simply take $13.33 and you add that to $740, and that gives you $753.33. Okay, so you can expect to see potentially a question like this on your exam because I will provide you with the answer report and the sensitivity report, and then I will want you to make sense of it. You have to interpret it. You can't do the simplex method on your exam because you can't use Microsoft Excel, so I will just give you the answer report and sensitivity report, and you have to be able to determine if I change your inputs, how does that affect your outputs? Okay, so 3 more questions. What if, suppose the profitability of the type 1 computer increases by $10? Okay, so what if supply chain does a great job and now the type 1 computers are more profitable because we've reduced our expenses and our profit goes up by $10. What do we do now? Well, the first thing we do is check, does it fit within the range of optimality? So increasing our profit by $10 on the type 1 computer falls within the range of optimality, so this model is still good. So that increases our profit by $10. So do we take $740 and add the $10 worth of incremental profit to the equation? So do we take $740 plus 10? The answer is no. And the reason the answer is no is because we are producing 9 of the type 1 computers. So our profitability goes up by $10 per unit, which is actually $90. So you're producing 9 of the type 1 computers. Your profitability went up by $10. That means your total profit would increase by $90, and therefore $740 plus 90 equals your profit has now increased to $830. Okay, our next question. Suppose the profitability of the type 2 computer decreases by $15. Maybe they had a marketing promotion and they wanted to drop the price of the type 2 computer. So let's check and see how that impacts our profitability. But first we have to determine, does it fall within the range of optimality? So for our type 2 computer, we are allowed a decrease of $20. So the profit decreased by $15. It falls within the acceptable range for this model. We are going to be producing 4 of the type 2 computers. So 4 computers multiplied by $15 worth of lost profit means profit will decrease by $60. So $740 minus $60 means your profit has now been decreased. Your total maximum profit has been decreased to $680. All right, and then our last question is, if an additional 3 hours of inspection can be obtained by paying a $2 an hour premium, what will happen to our company profit? Okay, so 3 hours of inspection, but we have to pay $2 an hour to get it. So inspection, our shadow price is $10 per unit. So we're going to get $10 worth of profit for every unit of inspection that we can get. We've been able to achieve 3 hours of additional inspection. We get $10 in profit, but it's going to cost us $3 to do so. So inspection shadow price is $10 an hour. We've got to pay $3 to get it. So therefore, because it's 3 units, our profitability goes up by $30. So 3 times 10 gives you $30, but we paid a $2 premium to achieve it. So that cost us a total of $6. 3 multiplied by 2 is 6. So $30 minus $6 is $24. Our profit has now increased from $740 plus $24 to $764. I promise you'll see a question like that again. Okay, so we have now ran through the computer profit example. We've done a couple what-if scenarios. So when our inputs change in the model, then we now know how to interpret those changes, and we have determined whether or not things are within the acceptable tolerance in the model that we've created. And for all the examples that we went through together, they do. And so you saw the impact to profitability and how that changed things.